a really interesting project, especially for me, my first venture into ice on a non-salty ocean. The Great Lakes can be thought of as an ocean in many ways, but the ice is fresh, and it's probably the place in the US where actually the Coast Guard have most interaction with vessels in ice, and so I think it's a really interesting case study from that perspective, and there's a lot that we can learn from the Great Lakes that could be applied to the Arctic, I think. My name's Andy Mahoney. I'm a research assistant professor of geophysics here at the University of Alaska Fairbanks, and I've been involved in several ADAC projects from the beginning, focusing on sea ice and sea ice hazards, and actually just starting to get into studying lake ice in the Great Lakes, helping out District 9. Broadly, it's the same. The ice gets in the way of the ships. That is the same in the Great Lakes as it is up north, and indeed down south in the Southern Ocean as well. In this particular project, we had a direct request from District 9 to provide some decision support tool that will help them evaluate ice conditions and potentially forecast ice conditions in the Great Lakes from a navigation perspective, so that they can help give advice to mariners and also determine how best to deploy their somewhat limited assets that they have on hand in the Great Lakes. I think the initial request we got referred to something like the Beaufort scale for winds, or the hurricane scale for hurricanes. The goal is to develop a simple metric that will run from 0 to 5, with 0 being effectively ice-free conditions, 5 representing the most serious ice conditions that you might expect to find on the Great Lakes, and use an algorithm that's already been put forward by the National Ice Center that involves measurements of the ice thickness, measurements of the ice concentration, the type of ice, a lot of things that are important from a mariner's perspective. Bundle those all up to create this one number. One of the new things that we're trying to do is not just take those observations from the icebreaker itself passing through the ice, but use satellite and model-based information so that we can calculate an ice condition index for the entire Great Lakes, not just where the ships happen to be, and also forecast it into the future. So we're working with the Great Lakes Environmental Research Laboratory, who have a model, a very sophisticated model for ice and water conditions in the Great Lakes. If there's an increase in commerce and industry in the Arctic, that's likely to lead to an increase in destinational type shipping. If you're building a new port facility somewhere, well, you've got to bring in the materials in order to create that port facility to begin with. Similarly, if you look at Prudhoe Bay in the 1970s, there was a huge sea lift operation to bring the materials necessary to construct Prudhoe Bay. And so if those types of economic developments take place at the same time as the environmental changes are happening, then we could see an Arctic that is more populated by ice-going marine traffic. The moment the forecast is more that the traffic will increase during the open water period, but of course that's always going to be pushing up against one end or the other of that, and you will be facing many of the same hazards that the folks in the Great Lakes actually face every single year. A natural follow-on, we think, is to take the lessons that we're learning, and we're learning them at quite a rapid pace because of the support and observations that we're getting from the Great Lakes, but apply that to the Arctic would be a natural next step.